All right, let's go ahead and get started here. We just took a look at the quiz that the students took in their last lesson. Now for them, that was 10 days ago. We had a week of spring break, well, a week of Thanksgiving break, and a couple of weekends to go with both on either end of that. So it's been a little while. We've been talking, though, in addition to going over all the stuff that was on the quiz, we've been talking a lot about triangles. Obviously, triangle class has how many sides? Three. Okay, we remember that much. That's good. Here's a question. If there's 3 sides in a triangle, how many angles are in a triangle class?
3.
Also 3, right? 1, 2, 3 angles. 3 vertices, 3 sides, 3 angles. Everything about a triangle is 3. What is going to be the sum of these 3 angles? Who remembers? Show of hands. What is the sum of those 3 angles? Sam? 180 degrees. 180 degrees in the sum of all those angles. And so if I knew 2 of the angles, for instance, class, if I knew that angle 1 was, let's just say, 63 degrees, and I knew that angle 3 down here was, say, 48 degrees, what might I do to find angle 2, Michael?
You would add the 2 degrees that you know, and then you would subtract them from 180.
Okay, so let's go and add the 2 that we know. 111 degrees, and then you said after you add them, you said subtract that from 180. So what would be then angle 2 up at the top of the triangle?
69.
69 degrees, good job. All in your head, fresh off Thanksgiving break. How many were thinking the same thing that Michael was saying there? All right, questions on that. We remember 180 degrees in the triangle. And if that's true then, class, how many acute angles can you have? 3. That's what I have right here. So because all 3 of these angles are acute, again, what does acute mean, Bryson? We're talking about an acute angle. What does that mean?
More than 90.
Not more than 90. That'd be obtuse.
Less than 90.
Less than 90, right? Smaller than 90. And all 3 of these angles, you notice, are smaller than 90 degrees. So if all the angles are acute, class, we would call this triangle an acute triangle. How many right angles can you have in a triangle, Jalen?
1.
Just 1. Think about it. If you had a second angle, that would be 90, and 90 more would already be how much, class?
180.
180. There's no degrees left for the third angle, right? So you can't have 2 right angles. Also, just picture it. If you had 2 right angles, what would be true about these 2 lines?
They're vertical.
They're both vertical to the base, but that means they would run parallel. They're never going to intersect, right? So that means if they're parallel, you don't get a triangle that way either. So at most 1 right angle in a triangle, correct? That means the other 2 angles both have to be what kind of angles, class? Acute angles, right? So 1 right angle, 2 acute angles could give you a triangle. What would we call this triangle then, class? A right triangle. Class, what do we call a triangle with a right angle in it? Right triangle. How many obtuse angles can you have in a triangle, Griffin?
1.
Again, just 1. Picture it. You have an obtuse angle here. If you had another obtuse angle there, the 2 sides are going away from each other, right? They're not going to form a triangle that way. So you could have 1 obtuse angle, but the other 2 angles, class, would have to both be acute. So you could have 1 obtuse and 2 acute angles. Class, what would we call a triangle with an obtuse angle in it?
Obtuse triangle.
So if all the angles are acute, class, acute triangle. If 1 angle is right triangle. If 1 angle is obtuse triangle. We also could classify triangles based on how long their sides are. For instance, in this particular triangle, all 3 sides are different. All 3 angles are different, which makes all 3 sides different. And if all the sides are different, there's no equal sides in the triangle, what do we call that triangle? All the sides are different. Elaine, do you remember? No. Luciana? Scalene, a triangle. Class, what do we call a triangle with all 3 sides different? Scalene, a triangle. It is possible for 2 of the sides to be equal, and maybe the third side to be a different length. If 2 of the sides are equal, let me come back to Elaine for redemption. Do you remember that one?
Is it equilateral?
Not equilateral. Corey?
Isosceles?
Isosceles. Class, what do we call a triangle with at least 2 sides equal?
Isosceles.
Isosceles. Now, equilateral, Elaine, would be if...
Is it angles or something like that?
No. Kirsten, help?
The
the sides are equal?
If all three sides are equal. So if it's not just two of the sides that are equal, but if literally all three sides are equal, then we have equilateral. And if two of the sides are equal, then we'd call it an isosceles triangle. Oh, what if, she mentioned all the angles. What if all the angles are equal, class? Then we'd call it an equiangular triangle. Now, technically, if all three sides are equal for a triangle, the angles will all be equal. So if it is equilateral, it will be equiangular. If it is equiangular, it will be equilateral. But class, which term means, quote, all sides equal? Equilateral. Which term means, quote, all angles equal? Equiangular. There we go. I want to make sure we keep track of those things. We're going to talk today about drawing a triangle. So you need to have some paper out. You need to have your compass, your protractor, and ideally a protractor with inch measurements on it and centimeter measurements on it. Now, if today you don't have that, we can make it up as we go along. We don't have to be super exact today, but tomorrow you will want to have some kind of ruler with you. So if your protractor doesn't have a ruler on the bottom edge, you want to bring a separate ruler with you tomorrow. For today, we'll just kind of do our best as we go along since we're coming off the Thanksgiving break. Look in your books on page 163, if you would, please. Page 163. And there's a couple different ways we can draw triangles. Okay, we can draw a triangle if we are given two sides and what we call the included angle. The included angle. What does this term included mean? Well, think of a sandwich. Okay? And you have a ham sandwich. That implies you have bread and bread. That's what the word sandwich implies. And what is included between the bread, class? If it's a ham sandwich, better be ham in there, right? Okay, chicken sandwich, you're expecting what in the middle? Chicken, not whatever weird tofu or whatever, burger, you expect it to be real beef, not whatever they serve from McDonald's, whatever, okay? So, anyway, right, so there's something included between. So, if you have a triangle, just observing up here, let's suppose you're given two sides. Let's call this side A and this side B. Which of these three angles, class, would be included between A and B? Angle 1 is included. You have a side, another side, and right in between them, like a sandwiched in between, you have an included angle. Does that make sense? All right, so look in your textbook at page 163, and let's look at the second example that they have on the page. It's letter B, down at the bottom of page 163. Notice they have shown a 0.75 inch side. They have a 1.25 inch side. And then they have a 45-degree angle that is included between them. Notice what they did, class. And I'm not going to use measurements for this, but you can see what they did. I'm going to show it on the board as well. They started by drawing one of their two sides. I believe they started by drawing the 0.75 inches. Which 0.75, class, what is that? 3/4, right? So as you're looking at your ruler, the 3/4 of an inch, right? And then they made a 45-degree angle. So, 45-degree angle. And then they measured off the 1.25 inches. They said right there. That's 1 and 1/4 inches. And they connected those two ends together. Does that make sense? Seem pretty easy? You measure one side, you make the angle, you measure the other side. Easy enough? You could also just start by making a 45-degree angle, then measure off 3/4 on one, 1 1/4 on the other, connect the dots down. Yes, sir?
When we're measuring with our inches on our protractor, are we supposed to put like the inch mark on the vertex?
So you would start with the 0, right? So on your ruler, you'd start with the 0 and you'd measure 3/4 of an inch, right? By the way, real quick, since it's been a while for many of you, as you read the ruler, here's 0, here's 1. Do you notice that exactly halfway in between is a pretty long line? That's a half. Does everyone see on your ruler where the 1/2 inch is? Now, look in between. It's not marked on your ruler. It doesn't say 1/2 on your ruler, but look where your half is and your 0 is. You see there's a not quite as long line in between those? Guess what that mark is?
1/4.
That's your 1/4. Do you notice there are some other markings that are not quite as long halfway in between those? Guess what those marks are? 8s. And the little tiny marks, how big would those then be? 16ths, right? So your biggest is half, a little bit smaller is 1/4, a little smaller than that is the 1/8, and the smallest lines are usually 16ths of inches. Some of your rulers don't have the 16ths. Some rulers don't have the 16ths, most of them do, so it just depends on your ruler. But that's how you would draw it if you have two sides and an included angle. We're going to do a couple of those here in just a minute. There's another way you could draw a triangle. And if instead of being given two sides and the included angle, you could be given two angles and the included side. Now coming back over here, class, let's suppose my two angles are angles 1 and 3. Look at my picture. Angles 1 and 3. Which side is the included side between angles 1 and 3? Angle B would be the included side. That's what they showed in the first example. Notice in the first example on page 163, they have a 1-inch included side. And they have two angles, 25 degrees and 75 degrees. Well, for starters, you would draw the 1-inch side. You would probably want to note where these marks are because of well, actually, I think most of our protractors at this point are good. We've got see-through ones. You're going to line it up on one end, class. You're going to put one of the angles. The first angle they said is 25 degrees. So we make a little mark and we draw a 25-degree angle. Now here's where it's tricky. Watch. The 75-degree angle's got to go at this end, right? So we line up our vertex here. Well, which direction is the 75-degree angle going to open, class? It's going to be opening this way. So we don't go over here and say, oh, there's 75 there. No, 75 here, 0, 10, 20, 30, 40, 50, 60, 75. That's the only trick when you're given the two angles, is that the second angle, got to make sure it opens the correct direction. 75-degree angle like that. All right? Questions, not asking could you do it on your own, but questions, do you understand basically what we're doing here? A Sam question.
Can you just draw a straight line?
I'm sorry?
Can you just draw a straight line?
Straight up and down? Better not, that'd be a 90-degree angle. They wanted a 75-degree angle. If I drew straight up and down, that'd be 90, right? So we don't want to just draw straight up and down. We're trying to measure the actual angle that they give us. Good question. Good, yes ma'am.
So the second line will always go this way.
If it's acute, for instance, what if, Elaine, they had a 30-degree angle, and they said the next angle was 110 degrees?
That way.
Well, starting here, it's still going to be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. There you go, Sam. 100, 110. It's going to wind up looking something like that. Does that form a triangle, class?
No.
Not yet, but what could I do?
Extend.
Just extend lines. Remember, lines can extend indefinitely, right? Arrows at the ends. Now, we usually just use line segments. We can always extend that line out to make it meet. Good question. Good. Other questions before we try a couple of these on our own? Michael? Or together, rather.
I think if so, like, if for like they only gave us one angle, but
Two sides.
Yeah.
You're talking about the
Yeah.
first example that we showed here?
Yeah. Why didn't we just like on B just connect the dots?
On B, what dots?
Like
They
the
did
last
connect the
side,
dots.
the third side that we did.
So they measured 3/4 inch, and if you're looking at the example, they put a little dot there, and they measured 1 1/4 inch, they put a little dot there, and they connected the dots. That is what they did. Yep. Let's try a couple of these together. Flip over now, if you would, to page 165. Flip over to page 165. And you can set your books on the floor. That might be a good thing to do. Set your book on the floor where you can still see it, okay, where you can still look at it, but it's not in your way. That way you have the whole desktop, whole work area to work. And on number 17, they give us what 3 pieces of information about the triangle they want us to draw? Griffin?
Which number was it?
Number 17. What do they tell us?
70-degree angle and included 1-inch side and an 80-degree angle.
All right, does everyone see we've got a 70-degree angle, an included 1-inch side, and an 80-degree angle? So class, let's start by drawing
A line.
1 inch.
Specifically, how long of a line?
1 inch.
1 inch side. You got to start with a line somewhere. Why not just go ahead and start off by drawing it 1 inch? Now again, if you have a ruler available to you, actually make it 1 inch. If you don't, just estimate about what an inch would look like on your paper, okay, and draw that. Now, once we've drawn our 1 inch side, we should probably now make what, Corey?
Angle.
How big of an angle?
70 degrees.
Sure, why not? Let's do the 70-degree angle. Now, Corey, I'm going to let you pick. Do you want to put it on the left side or the right side?
Left side.
Let's put it on the left side. That's the easy side, right? Because that's what we're used to. So line up your protractor here at the left end of the line and mark a 70-degree angle. It should be an acute angle, remember. Now, strategy tip. Remember I told you that we might have to extend the lines to make them meet? You know how you can bypass that? Is when you draw this line, draw it nice and long right off the bat. If you draw it nice and long to begin with, you minimize the chances of having to extend it later because, we're lazy. All right, the only thing left to make now, Ben, is the
80-degree.
80-degree angle. Now be very, very careful. We've got to put the protractor at which end of the line now, Ben?
Right.
The right side. And we're not used to that, okay? So we're going to have to use the opposite scale of what we're used to. Make sure you find the one that starts here and goes 10, 20, 30, 40, 50, 60, 70, 80. It's going to be just a little bit inside of being straight up and down. And make your 80-degree angle. Now you can tell I didn't take my own advice here. Because what am I going to have to do, class?
Extend.
I'm going to have to extend these lines to make them meet. I hope they meet without going off the chalkboard. It's going to be close. Yeah, not quite. They're going to miss. They're going to extend somewhere right up here about the top of where the chalkboard would be on mine. Hopefully you can fit them on your paper. If not, oh well, we live and learn. Does it make sense how to draw a triangle if you know two angles and an included side? That seemed pretty easy? Not too hard? All right. How many got your triangle to finish forming? You had room for your triangle to complete. How many, like mine, you just kind of ran out of room at the top of the paper? Yeah, these things happen. Let's take a look at number 18 now. And what are the three things we're given in number 18? Luciana?
4 centimeter side, 35-degree angle, and a 2 centimeter side.
18?
2.
2 centimeter side.
Yeah, 2.
2 centimeters. I don't know where I heard 18 from. 2 centimeter side. My bad, my ears. All right. I was about to say, that's going to be a really big triangle. All right. Now, strategy tip. We obviously, class, have to start by drawing some kind of line. I would suggest always start with the longest line. Or longer line, I guess I should say. Start with the longer of the lines. So I would start with a 4 centimeter side. Now again, if your protractor or your ruler doesn't have centimeters on it, just draw a line and say it's 4 centimeters. But if you have a ruler that actually has centimeters, go ahead and measure exactly 4 centimeters on your line. How many do have centimeter markings on your ruler?
4 centimeters.
How many don't have any centimeter markings? You're like, oh, mine doesn't have them. A little less bigger on your erasing there. We don't want to tear your paper to shreds. All right, just move down the page a little bit, Sam. Slide down. There we go. So we're out of the way of the shredded portion. All right. Once we've drawn our 4 centimeter side, do I go ahead and draw the 2 centimeter side, class?
No.
No, because you don't know where to put it. So what has to be the next thing you do after you draw your long line?
Angle.
Make the angle. Now, Kirsten gets to pick. She can go either left side or right side. Where do you want to go, Kirsten? Left. Left side's the easy side, so we're going to go to the left end. And again, it's going to be a little bitty acute angle, 35 degrees, not real big at all. And now the only thing left to have to do once we've drawn our 35-degree angle, class, is to measure
That's just a side.
2 centimeters on this line. So we're going to start here and measure off 2 centimeters. Now again, I don't actually have the measurements here, but I'll just kind of eyeball it, say maybe 2 centimeters looks like it's right about here. But take your ruler, if you have centimeter markings, and measure 2 centimeters. If you don't, just guesstimate about half of what you did for the 4 centimeter line, roughly. And then, how do I finish the triangle? Because here I just needed to extend the lines till they met. What do I need to do here to complete the triangle, Jalen?
Straight line.
Just connect wherever your 2 centimeters ends to the other end of the 4 centimeter line. Just connect the dots. And that'll complete your triangle. All right? Feel like we've got the idea here.
Yeah, I know.
All right. Tell you what, why don't you tackle number 19 at your seats? I'll do it at the board as well, but you get a head start on it. Do number 19 there at your seats. If you need to look up at the board, that's fine, but see if you can do it on your own. Again, we're on page 165, number 19. Did we start with the 5 centimeter side?
Yes.
Good. You don't have to put the 40-degree angle at the left end. I did. How many also put the 40 at the left end? How many put the 50 at the left end? Okay, nobody did that? Okay. You don't have to put 40 and then 50. You could do 50 then 40. It really doesn't matter. As long as you make sure you have it opening the correct direction. We should have another acute angle here. And how many do have a picture that looks like this? By the way, how big is the third mystery angle, anyone? 90 degrees. Good, Jalen. Because we have 90 degrees here, that means this should be a perfect 90 up here at the top of the triangle. How many had that for 19? All right, do we feel good about 2 angles and 1 side? That's pretty easy. Any questions on 2 angles and 1 side? All right, let's tackle number 21. Let's drop down to number 21 now. And let's practice 2 sides and an angle. Make sure we're good on 2 sides and an angle. Start with a 1-inch line. did you then put a 30-degree angle at one end of the 1-inch line? And then, what do I have to do next?
Measure the 33 side.
On this line, from here, measure how far, class?
1 inch.
Measure 1 more inch. Let's just say it's right about there. And then I don't have a triangle yet. What do I have to do to finish the triangle, class? Connect the dots. You're going to take the straight edge and just connect the dots down. Now, question, what kind of triangle is this? If it's drawn perfectly, and I don't know that mine is, but if it's drawn perfectly, what kind of triangle would I have here, class?
Right.
Right.
Acute
And a
right?
Right.
two sides are equal. Isosceles. We have an isosceles triangle. Now it's laying on its side, right? We're used to isosceles triangles having the equal sides up like this. It's just laying on its side, but if there's two 1-inch lines, it's gotta be an isosceles triangle there. So, good. Questions on this? Let me have you do numbers 20 and 22 at your seats. You do both 20 and 22 now. And I'm going to use actual measurements this time, but obviously I'm going to have to make them bigger for the sake of the chalkboard. On number 22, and it says 35 millimeters. What in the world? Class, how many centimeters would this be? Ooh, careful, other way. Going from milli to centi. 3.5. Right, 3.5 or 3.5 centimeters, right? 65 millimeters. How many centimeters is that, class? 6.5. 6.5. So we're going from milk to chocolate, boinking one place that way. So 3.5 centimeters, 6.5 centimeters. Be a little easier way to think of it rather than in terms of millimeters. And that's a lot of little lines to count. We don't want to do that. Agreed?
Yep.
You lazy? Are we all good on number 20, by the way, with the right triangle, the 90-degree angle, 20-degree angle at opposite ends of a 3-inch line? And number 22, I put my 120 degree angle on the right end. Only because if I put it here, it was going to run right into my writing. Okay? So I didn't want to run into my writing, and I was too lazy to redraw the line, so I just put it on that end. But there's nothing wrong with having your 120 degree line going this way instead. The question is, I draw my 65 millimeters, or 6.5 centimeters. I drew my 120 degree angle. Where do I measure off my 3.5 centimeter line? On the second line I drew. I need to start here, and I'm tripling everything, so let's see. 3.5 triple 21, and or times 6 rather. So we're going to come here, and that's going to be proportionally my 35 millimeters. How do I finish the triangle? I've got my 65 millimeter, I measured up 35 millimeters on the one side. How do I close it off, class?
Connect the dots.
Connect the dots. The end point here, the free end here, to this other little mark here. Now again, yours will look like it's flipped around compared to mine probably. Because most of you probably put the 120 over here. But how many of you just got flipped it like that, you've got the same thing? You got the same question. Yes, sir?
What if we did it like the complete opposite way? I did 35.
And did you perhaps have it if you flipped it like that?
Yeah.
And if you look at it like this, this is what you had? Yeah, that's fine. Yeah. Good question. Yes, ma'am.
Mine seems longer than yours, like longer.
Proportionally. So let's see. Here we've got, that looks like 3.5 there. Oh, you went really big here.
Oh.
You didn't measure 6.5. So that's that. So if we were to start here again and measure to the 6.5, and you just connect it to that point, that would be the same.
Oh.
Good question. Good. Other questions on drawing triangles? Questions on drawing triangles. Look at the top of page 164, and they show you how you could draw an equilateral triangle. An equilateral triangle. Remember, I said if a triangle is equilateral, look back across the page, page 164. If a triangle is equilateral, class, it's also going to be equiangular, which means, remember, what's the sum of the three angles?
180.
180. But if all three angles are equal, how big is each angle going to be? 60 degrees. So you could draw any length side you want. So on your paper, go ahead and actually let's make it. Let's go 2 inches. Let's draw, if you would, on your paper a 2-inch long line. Go and draw a 2-inch long line. And we said every angle is going to be how big, class? 60 degrees. If it's going to be equilateral, it's going to have to be equiangular. For a triangle, that's true at least. And that means we're going to need 60 degrees. So go to one end of your 2-inch long line and draw a 60-degree angle. Then go to the other end of the same 2-inch line and make another 60-degree angle. How big should the angle at the top be?
60 degrees.
Should be 60 degrees. You can check it if you want to with your protractor. Make sure it comes out to 60 as well. Mine's a little bit off, which is disturbing. You could also then measure your other lines and make sure they're also 2 inches all the way around. If it's done perfectly, you should have an equilateral triangle. Questions on that? Just a little fun fact that they've got there. Questions on that? Let's do number 23 now. Let's do number 23. We technically already did 24 there on page 165. We had a 2-inch side. Let's do a 4-centimeter side. Again, if you don't have centimeter markings, just make something up. But go ahead and do a 4-centimeter side. It's going to be a little bit smaller than 2 inches. What's another way we could do it besides doing 2 60s at the ends, class? We could just do 160, right? We just do a single 60, and then on the 60-degree angle, class, measure off instead of measuring another 60-degree angle, what might we do?
Measure 4 centimeters.
Measure 4 centimeters here. And once you've measured off 4 centimeters, should be able just to connect the dots. And it should be another 4 centimeter side. All the way around. So 2 different ways you can make an equilateral triangle. You doing this with me, Ben? Questions on this? You pick how you want to do number 25. It's a little bit bigger, so you might need a little bit more space on your paper. They got 3.5-inch long side. You can either do the dual 60-degree angle method, which probably is the easier way to go, honestly, or you could do the 3.5 centimeters or 3.5 inches, 60-degree angle, another 3.5 inches. It's up to you which way you do it. But go and do number 25 now there at your seats. Do number 25 there at your seats. An equilateral triangle with 3.5-inch long sides. Any questions? Drawing triangles? Seem pretty easy. Not blowing anybody's brain the first day back after Thanksgiving? I blew Michael's brain. What happened, Michael?
It's just like so big.
So big. It's only 3.5 inches a side. That's not that big. We'll plant more trees. We get to get more paper. It'll be okay. Paper's a renewable resource. All right, questions on this? Now, a few things to note, by the way, if you would, look at page 164 and put a little star next to the 2 paragraphs here. You see next to the little blue boxes? It says 2 rules apply to drawing triangles. 2 rules apply to drawing triangles. And this first thing is implied, but it's not written, so write this off to the side. You must be given 3 pieces of information. You must be given 3 pieces of information, 3 parts, if you will. Now, you say, but Mr. Nadasky, a second ago, all it said was a 3.5-inch side. That's only one thing. Well, no, it's not, because what do you know about the other 2 sides? They're also 3.5. You also know there's 60-degree angles. You actually knew all 6 parts of the triangle, right? But you must be given 3 parts, either 2 angles in the included side or 2 sides of the included angle, right? That's 3 parts you have to know. If you don't know 3 parts, you really don't know what you're doing. Okay, so you got to be given 3 parts. Also, one of the parts you're given must be a side. Think about it. What if I told you to draw a triangle that has a 31-degree angle, a 57-degree angle, and a, let's say, a 92-degree angle? By the way, what must be true of those 3 angles, class?
Add up to 100.
Have to add up to 180, right? Well, how big of a side do you start with? Somebody might start with a little bitty side. Somebody might start with a bigger side. But you draw your 31-degree angles. You draw your 57-degree angles. And you have your 92-degree angles already there. what's going to be true about the triangles we draw, class? They will be similar to each other, right? They'll have the same shape, but unless you know a side, you don't know how big to make it, correct? So jot this off to the side as well. If you're given three angles, there are infinite triangles that could be formed. They'd all be similar to each other, but there's infinite triangles that could be formed, so that's no good. So one of the things you must be given is a side. You must be given at least one side. Without a side, you know nothing, because you don't know how big to make it. Does that make sense? All right? So you got to be given three pieces of information, or three parts, but they can't be all three angles, because you have too many possibilities. You have infinite possibilities. You must be given at least one side. Now, what rules must apply then? If you're given one side and two angles on either side of it, what has to be true about the two angles? The two angles have to add up to
180.
less than 180, correct? These two angles have to add up to less than 180. What if they add up to exactly 180? These two lines are going to run parallel to each other. If they add up to more than 180, they're going to be going apart from each other. So the two angles have to add up to less than 180. Do you see that in the little yellow box? Number one, the sum of the given angles, if it's more than 180, you cannot get a triangle. Triangles cannot be formed when the sum of the given angles is more than 180 degrees. Does everybody understand that? There's another rule that's kind of interesting. And you don't know how to construct this yet. You won't learn this till you're a little bit older. But what if you're given all three sides? Well, look at the picture that they have there. They have a 1 inch long line, they have a 1/4 inch long line, and a 1/2 inch long line. Wait a second. If you have 1 inch here, and you try to go in a 1/4 of an inch, and you try to go in 1/2 an inch, are those two lines ever going to meet up? Let's use easier numbers. Let's say you start with a 4 inch long line, and you try to draw a 2 inch long line and a 1 inch long line. Are the 2 inches and the 1 inches going to be able to reach each other?
No.
Not if they start 4 inches apart, right? What if they were both 2 inches? Then could they reach each other?
Yeah.
Yeah, but they would still be right there, wouldn't they? They wouldn't be up. So what must be true? The two little sides together have to be bigger than the third side. Does that make sense? The two little sides together have to add up to more than the big side. Look at the yellow shaded box again. A triangle cannot be formed when the sum of the two shorter given sides is less than or equal to the longest given side. Does that make sense? Now let's look at some problems that talk about this. Look at number 26, back over on page 165 now. Why can't you get a triangle from number 26? Look at what they tell you in number 26. Why can you not get a triangle from that? If they told you to draw that, you're like, yeah, I can't do that. Why that a problem, Michael?
Because the two sides the two angles you see don't add up to 180, they add up to 190.
They add up to more than 180.
Yeah.
They have to be less, and they add up to more than 180. So, yep, number 26, the sum is bigger than 180 degrees. Look at number 27. What's the problem with number 27, Kirsten?
It adds up to more than 180.
It adds up to more than 180 again. It can't add up to more. It can't even add up to 180. It has to add up to less than 180. Look at number 28. Why can't you get a triangle from those sides that they give you there, Jalen?
The angle is not given.
Well, now we couldn't draw it yet, but later years we could. There's a bigger issue than just no angle being given. Look at how long those sides are. 7 inches, 12 inches, and 4 inches. Sam?
Is there not an angle there?
Well, that's what she said. Again, for our purposes, with our limited knowledge of triangles, we need an angle. But there's something wrong with the lengths.
They wouldn't be able to connect.
The two little sides, 7 and 4, can't reach each other if they start 12 inches apart, right? So the two short sides are too little to reach each other. The sum of the shorter is less than the big. Does that make sense? The sum of the littles is less than the big. Look at number 26. What's wrong with, well, for one thing, what ain't we been given on 29, class? A side. You have to be given a side. But even more than that, what's another issue with number 29? Bryson?
You add up to, it adds more than 180.
Yeah, it doesn't add up to 180, right? The sum is greater than 180. You can't get a triangle with that. How about number 30? Class?
No
Side is
side.
greater than 180.
Again, no side given, and the angles add up to more than 180. You can't draw that triangle. What about number 31? Again, for our purposes, I know we would want an angle to be given, but what's the real issue there on 31? Griffin?
Two of the sides are smaller than the long, or smaller than the.
Well, it's actually not smaller here. They're actually exactly equal to. But again, that means they're just reaching each other. They can't open up above to make a triangle. So the two little sides equals the long side. They have to be bigger than the long side. All right, your homework for this evening is page 167, numbers 15 to 29. Page 167, numbers 15 to 29. I want you to read over pages 167 to 168 as well. So read pages 167 to 168, previewing what we're going to talk about tomorrow. Also, on page 167, do 15 to 29. Make sure you bring your compass, your protractor, and also bring a ruler tomorrow. Now again, if that ruler's on the protractor, great. But bring a ruler to class tomorrow. Have a wonderful rest of your day. You are dismissed.